So perfect square trinomial is formed by the product of two identical binomials. So if you square them, you get the same thing. So like p plus q squared would give you p squared plus 2pq plus q squared. Conversely, with the minus, the same exact thing, but instead of a plus here, it's a minus in the middle. So p squared minus 2pq, still plus q squared because it's a negative times a negative. So you can see that the first trinomial is the square of p, or the first term. So p squared, just going along with that pattern. You can see that the middle term, or excuse me, the last term, is the square of the last term. And the middle term is twice the product of the first and last term. So p times q times 2. We've already talked about this pattern before. Okay, going further. So example 1, let's give some examples here. It says, which of the following are perfect square trinomials? Okay, is A. Yeah, it's what? It's a plus 2 times a plus 2, which is a plus 2 squared. So this one's a yes. Okay, how about B?
Yes. It is. No. Never mind.
Well, you're thinking 3 plus 3, right? So there's no factors of 6 after that. I can't even factor this one, actually. So this one's no. Okay. Part C. Now this one, in order to factor it, what do we have to do? Well, can we pull anything out? Good question. 4 goes in 81? Nah. Sketch. Exactly. Okay, this is where we're going to do decomp. So this is the one where a is not 0, or excuse me, not 1. So I want to go 4 times 81. That's going to give me a big number, 324. And we want to think about factors of 324 that are 36 apart. So you're going to have to really kind of play with that one to figure that one out. But if you want to look at the patterns, let's pause for a second. If you're trying to crunch some numbers, pause for a second.
Yes, no, yes, no.
We know that the first number is squared and the last number is squared, right?
Yep.
From the pattern. So what's the square root of 4? 2. So 2x. What's the square root of 81? 9. And it's a minus. So let's see if 2x minus 9 works. Okay. So what's 2x times a negative 9? What's negative 9 times 2x? Negative 18. What's negative 18 times 2? Negative 36. So does this work? Yes. So that way I just use the pattern, right? Save yourself some time. And the last one there, no. When I look at D, immediately I can say no because of why. Say that again, Chris? That too. But there's one thing immediately I see, I'm just automatic. Yes, yes. This can never be negative. Because if that's negative, then what? The signs are different. The signs are different. It's not a perfect square trinomial. Okay, so as soon as I saw it negative, I said no. Okay, so now they want you to work backwards here. What would the middle be? So it gives you the outside. So what would the middle be? So use your pattern. That's an x. Square root of x squared is x, right? Yeah. Square root of 100 is x times 10 is 10x times 2 is 20x. That's the pattern from the top. Times them by each other. Because this is x plus 10 squared. So conversely, this one's going to be x minus 10 squared, which gives me minus 20. Ooh, tricky. Third one. Well, this is going to yield a 5x. This is going to do a 6. 5 times 6 is times 2, so 60x. So now let's work backwards a little bit. So I know I have a 3m. What's 24 divided by 2? 12. How do I get a 12m from a 3?
4.
By 4. What's 4 squared? 16. Just got to work backwards on that one. Very good. All right, this last section here, and then let's just try a couple. Okay. So factor 49x squared minus 14x plus 1, 7x minus 1. This one's written backwards, no big deal. 4 plus 5x. Is 1/9, can I take a square root of that?
Yes.
To get a perfect,
No.
to square root something and get something to come out cleanly, the top and bottom have to be perfect squares. Is 1 a perfect square?
No. That is
9?
Yes.
So what's the square root of 1/9? 1/3. Okay, square root of 9, 3, that's a minus, so I want that right there. Okay, go ahead and pause here for a second. All right, so now we're going to move to kind of understanding that you can factor. A lot of things have to have a factoring pattern. And so by that we mean we have factor trinomial as a form of f squared plus bf plus c, where f's a monomial. So what it means by that is if we've been dealing with x squared and then bx. Well, this x in the middle has an exponent of what? It has an exponent of 1. So the relationship from the first exponent and the middle exponent is 2 to 1. That's the main point. Is that okay? So the exponent relationship between our regular factoring right now is 2 to 1. So what we're going to learn now is you can factor something from 4 to 2. Everything's the same, but it's just the pattern. So like you would still factor this right here using regular inspection. So factor the 6 to add to 5 is still the 1. Where's it at here? Or the 3 and the 2. So 2, 3, but they'd be x squareds now. Okay? So we're concentrating on understanding the pattern. So let's do this at the same time. X squared plus 5x plus 6. So this is what we're comfortable with. X squared plus 5x plus 6. And if I told you to factor that, you guys would say x plus 3, x plus 2. Okay? So what I'm showing you is that notice that that's the middle of an x. And notice we use x's to start. Well, in this one, the middle is a what? It's an x squared. So that's why they use x squareds to start, and it's still your same 2 and 3. Okay, so the only thing that changes is the pattern of the x, like what x squared you're using. Okay, so maybe I see a little bit of confusion, so let me try to get an example going here. Okay, so here I have A4 and an A2. Is that in a 2 to 1 ratio? Yes, it's double what this is. Okay, so then we need to factor. So now what's multiples of 14 that gets me negative 5? Negative 7 and 2. So I just go, okay, I have a minus 7, I have a plus 2, so then what goes here? A squared, and you're done. Any questions on that? Okay, let's keep going then. 4, 2, it's 2 to 1. Okay, so I know, I'm just going to put this now, I know these are x squareds. Factor the 5, they're 4 apart. Positive 5, negative 1. So plus 5, minus 1. Okay, this is where they want you to try to be a little bit advanced here. What's the x squared minus 1 also? What's this?
Just 1.
the difference of squares. Get the x squared minus the 1. 1's a perfect square, x squared is a perfect square, so I can break this down one more step further. So it can be like this. X plus 1, whoa, and an x minus 1. That's all I'm saying. You can break that down to this. Questions, concerns yet? Okay, so this one has a 6 and a 3. Is it still 2 to 1? Yeah, so we can still do it. So I just know that now I'm going to have an x cubed here. Okay, factors of 14 that add up to 9. -7 and -2, right? And you leave it at that. Okay. Okay.